In this delight lecture, we will learn about the drawing curve and the constant rate drawing or the constant rate period, the falling rate drawing and the corresponding term falling rate period, critical moisture and equilibrium moisture. Equilibrium moisture we have already studied while defining the four types of moisture content in the wet material. Let me explain the curve first. This is the curve rate of drying in kg per meter square per hour versus the kg of moisture per kg of dry solid. The drying is commencing here at point A or A dash and along the curve B, C, D up to 0. To know or to learn the constant rate or falling rate, critical moisture, all these terms or terminologies, we must know the concept of drying, which we have already studied. Let us have some more focus on the concept of drying. Concentrate on this figure. This figure or this situation is representing the constant rate period or constant rate drying. Initially, when the material is kept for drying, means initial condition, the drying is just begin. Drying has just begun. At that condition, the wet material is fully moisturized. The wet material is used to be fully moisturized in such a way that the whole material and its surface is covered with moisture. A small or a thin film is spread all over the material. The thin film of the moisture or water is spread all over the surface of the material to be dried. When we allow the air, drying air or the drying medium or any gas to pass over the wet material, due to the difference in relative volatilities, the moisture evaporates. The thin film over the material to be dried, that is wet material or wet solid, undergoes evaporation. There is only one resistance for the mass transfer, and that is gas film resistance or the air film resistance. So the moisture is evaporating from the thin film which is covering the surface of the solids to be dried, that is wet material. This stage is simply similar to the evaporation of water from its surface when it is free water. Just I have explained in the previous video. If water is kept in a still or a vessel, and if the evaporation is taking place, the evaporation will take place from the surface of the water, just like that. The thin film of the water or the moisture is covering the wet material, and the moisture is getting lost from the thin film. So that point is represented by point B. This film evaporation will continue till point C. It will be constant rate period. Why constant rate period? Because the thin film consisting of moisture or water have enough water to be evaporated at constant rate. The thin film water has only one resistance, and that is air thin film resistance. So the water is getting evaporated at constant rate. Now coming to the CD part of the drawing curve, which represents the falling rate period. Concentrate on the next diagram on the board below constant rate diagram. The moisture is well evaporated at up to the condition C. Now at condition C there exist two resistances. Which are there? The first is airflow thin film and another one is the resistance of the vapors of the water, which the vapors which are diffusing from the water in the capillaries or interstices. The initial water is evaporated. Now the water well inside the material which is trapped in the capillaries or the interstices of the wet material, that will evaporate in subsequent drying along the curve CD. That will evaporate and the vapors will accumulate at the space which is left by this thin film of water after evaporation. So the vapor film resistance and the gas film resistance, both the resistances are there. Also, it takes some time for the water evaporated to reach the surface of the drying material. Water is evaporating here in the capillaries and interstices. They travel to the interface of the dry material to be dried and the air film and the wet material surface, that interface. The vapors or the moisture getting evaporated will travel to that interface. So that traveling period will consume some time. Also, it has two resistances, the vapor film resistance and the gas film resistance or air film resistance. So that diminishes the rate of drying. Hence, after point C, we are able to see on the drying curve that the rate of drying is falling. So this period or this region is known as falling rate drying or the falling rate period. Here the film evaporation is taking place, the film which is uniform all over the surface of the drying material, the wet material. Until the film exists there, the rate of evaporation will be constant, as enough water is there to be evaporated. Here enough water is not available. The water available for drying, for evaporation, is only the water trapped in the interstices or the capillaries. Here only one resistance exists, that is the air film resistance. Here two resistances exist, the air film resistance and the vapor film resistances. The vapors generated deep inside the capillaries and interstices has to travel to the interface first and from the interface to the bulk of the drying air. That's why the rate is decreasing. Therefore, this film evaporation or film moisture loss is B represented by the part BC of the drying curve, and which is the constant rate period. See, it's the rate of drying. The rate of drying. If to the abscissa, the rate of drying is perpendicular. I mean, this BC line is perpendicular, means it is horizontal to the x-axis. So that is a constant rate period or the constant rate drying BC up to point BC. After C, with reference to this figure, the rate of drying is decreasing, falling rate period. So this point C, what is the speciality of point C? Point C is the point on the drying curve up to which the constant rate period lasts and the following rate period begins. What is the speciality of point C? Up to point C, the constant rate period lasts and the following rate period begins. This point C is known as the critical moisture point on the drying curve. So point C represents critical moisture inside the material to be dried or the wet material. So corresponding critical moisture would be represented by XC, C suffix for critical moisture. Point D is known as equilibrium moisture point, or it is the equilibrium moisture content in the wet material. We have already seen the definition of equilibrium moisture content. Equilibrium moisture content is the one referring to the equilibrium set between the drying air and the wet material humidities. No further drying is possible beyond point D or the beyond point equilibrium point. The equilibrium moisture content is represented by X star. Star represents the equilibrium condition. So X star. So that is all about the drying curve. It's constant rate period. It is constant rate drying from B to C. Falling rate period from C to D. And C is critical moisture content and D is the equilibrium moisture content. There is one more term, and the term is initial period of adjustment. The air flow which we are allowing to pass over the material to be dried has some specific temperature. The material to be dried may have three conditions with respect to that temperature. Either the material to be dried is at the same temperature at which the air is allowed to pass over for drying, or it is greater than the air's temperature, or it is lower than the air's temperature. If it is greater than air's temperature, the material or the drying process has to take some time to stabilize or to adjust. So if the means it has to reach to the temperature equal to air's temperature. So if it is greater than air's temperature, it has to lag the time in reaching to that temperature. So if the temperature of the drying material to be dried is more than the air's temperature, the drying will commence at point A dash and it will come to point B. So this is the initial period of adjustment. At point B, the material to be dried has the temperature equal to the temperature of the air used for drying. If the material to be dried, or if the wet material's temperature is lower than the air's temperature, then the material has to reach or gain the air's temperature. So that is the equilibrium point, or the equilibrium has to set between the air's temperature and the wet material's temperature. So the time being lagged in establishing or achieving that equilibrium temperature between air used for drying and the material to be dried. So that lagging period is known as initial period of adjustment. Period A dash B for the material to be dried having temperature more than the air temperature, and the region A to B is the initial period of adjustment if the material having temperature lower than the air used for drying. So these are the points on the drying curve. The constant rate period or the constant rate drying can be represented by an equation. The equation is RC is equal to KY in bracket YS minus Y, where KY is the mass transfer coefficient of the air film, the air which is used for drying purpose. YS is the humidity of gas means air, the air which is the medium used for drying. So humidity of gas here In our case, it's air, humidity of air at interface. So humidity of air at interface. Interface between the gas and the solid material. So it's YS, humidity at the interface. And Y. Y is the bulk humidity of the gas or bulk humidity of the air. Bulk in the bulk. Ky is a constant quantity. Ys is a constant quantity, and Y is the bulk humidity. We are using the air with constant humidity, for example 60% humidity or 80% humidity or whatever, depends on the situation. So Y goes to be constant. Ys is also constant because the film accumulated at the interface is free water, just like water in a steel. That's why the water being evaporated and the bulk humidity, the water or the moisture in air at the interface with respect to bulk humidity. So that the humidity of gas at the interface in turn becomes constant. So if all these terms are constant, then Rc would be constant, where R stands for the rate of drying and C stands for constant. It's constant rate of drying. That's why the drying represented by curve BC is constant rate period drying or constant rate drying. So that's the equation representing that situation. The situation shown by BC part of the curve. Thank you.